Okay.
I know.
All right, so Victory's up here doing what I asked. He's trying to graph some of these things. We need to not only review our shapes, which some of you have mastered, but we also need to review what all these numbers do. So, the first one, okay, I'm not going to talk over you. The first one is what shape?
V.
A V. And it has been moved how? When you start putting these adds and subtracts in, you're moving it how? Up. This goes up one. So we get in a habit of labeling our important points, and certainly the V vertex is an important point. All right, so up one. This number, look where it is. That position moves us up and down. Now, when I look at the second one, that number is in a different spot. That number is not on the end. That number is right inside with the X. So this is going to be a parabola, squared parabola, and it's going to move 2 units to the right. Okay?
So, well, do you not square that's -2?
Nope. Nope. This is x squared moved over 2 units to the right. Now, tell me what's happening to my logarithmic function here. Is this movement going to be up and down or left and right?
Left and right.
This is going to be left and right, and it's actually going to go to the left. So, keep in mind what your regular BFF looks like. It looks like this. That's your regular BFF. The entire thing, everything, backs up 1 unit. The entire thing. So that asymptote is going to back up to -1. And that dot is going to back up to the origin. And then you have your shape. All right? You got to know your BFFs so that when you have a problem like this, you can move it as appropriate. All right, tell me what's happening to the next one. Up, down, left, right. It's going down 2. That's exactly right. Kids, if we were going to move it left and right, it would look something like this. See the difference between where the 2 is there and where the 2 is here?
Yeah.
That moves it left and right. When you're doing it to the x, it goes left and right. Here, we're just putting a -2 on the end. So this is going to take our regular e to the x. And again, I know what it looks like because I have memorized my curves. And it's going to drop everything down 2. So the asymptote was at 0, so now it's down here at -2. The dot was at 1, now it's down here at -1. So it doesn't have anything to do with the shape. It does not change the shape at all. It just picks it up and puts it down someplace else. Yep.
Why'd you, for the last one, you put the L and then parentheses X plus 1?
Uh-huh.
You moved it to the -1. Did you just turn it into a 0? You can make it equal 0?
Yeah.
Okay.
Yeah. You can think of it like that, yeah. All right. What shape is this one? Parabola.
Yeah.
Instead of being at the origin, though, where is it going to be? Up 3. There it is. Moved up 3. It's just your regular parabola moved up 3. What What shape is this one? A V? Absolute values are V's.
Yeah, 4 to the left.
4 to the left. Just your regular V, it just moved 4 units to the left. What shape is number 7? The squiggly. And the normal squiggly, guys, the normal squiggly squiggles at the origin, right?
Yes.
Where is this one going to squiggle?
Negative
To the right.
2 units to the right. So you're gonna have your squiggly 2 units to the right. So the shape is the same, we haven't changed anything that way, we just changed the location. All right. Oh, what shape is number 8? It's your identity that normally would go through the origin, right? That's the normal one. What have we done to this one?
Move it down.
Down 4. So if I bring this point down 4, won't my line look like that?
Yes.
It's the same line, just drop down 4. Show me in the air, what shape is number 9? This one, right? So normally that would look like this, right? Where has this one moved? 3 units to the left. Here it is.
Wait, why is it, -3?
This moves you left 3. Please memorize that. That's a movement 3 units to the left. Navi thought about it like x plus 3 equals 0, so x equals -3. That's how he thought about it. It works for him. And then x cubed plus 2. Well, that's my squiggly here, which I'm just erasing. What does x cubed plus 2 do? Up to. So up to means that the squiggly is now up here. So there we go. All right, so that's it for that review. Turn that over, and there's a little bit of space on the back side, not much, I don't even know what's on your back side. But here's what we're gonna do now. I want you to practice this one more time. So f of x is 2x minus 3, and g of x is 5x plus 1. Just 2 random functions. I just totally made those up. They're not special. They're not anything. I want you to do this problem and this problem. So take a second. That's just a little review of what we did today. All right, so did you remember that to do the first one here, You plug 2 into your f function. What do we get if we plug 2 into our f function?
One.
We get 1. Everybody agree with that?
Yes.
Then we take that 1 and we plug it into our g function,
Yes.
and we get 6. How many of you got 6 as your answer to the first one? Awesome. Good. Now, the second one is exactly the same, except we're working with letters instead of numbers. So f of x is 2x minus 3, period. Then we take the 2x minus 3 and plug it into g. So that means right here goes 2x minus 3. So 5 times 2x minus 3 plus 1.
10x minus 15.
So we get 10x minus 15 plus 1, 10x minus 14. How many of you got that one by yourself? Oh, that's wonderful. If you didn't get that one, let's back up and make sure you see the steps. I think almost everybody got the first one right. So you knew you put 2 into F, you got 1, take the 1 and plug it into G. Here, plug X in, you get 2x minus 3. Take the 2x minus 3 and plug it into G. So 5 times 2x minus 3 plus 1. And then just do the arithmetic to clean it up. All right, tomorrow we'll have our second BFF quiz.